Well, welcome everybody to another edition of How Do You Solve Quadratic Equations? Equations where the variable is being squared. How do you do that? So we are on to level 3. Okay, so these are going to be level 3 Quadrus method, meaning we're going to solve them with the square method. We are going to take advantage of the beauty of symmetry. I even brought the whiteboard outside today so you could see the beauty in nature. That ain't like a green screen back there. That's nature. All right, well, let's get this going. I think you'll like level 3. But the first thing you're probably thinking to yourself is, wait, that looks different. Like, because that was a level 2, right? Where you had something squared is equal to something else. Now you've got all of this equal to something else. So you might be asking yourself, oh, wait, these look different. But here's the power of the Quadrus method. No matter what level it is, we're always just going to make it look like a level 2. So if you can do a level 2, you are in really, really good shape. So let's talk a little bit about area. X squared, we know what that looks like. We've got x squared, so I'm going to put an x and an x there, plus 6x. Well, I can do that because I know this dimension is x. Now, theoretically, I could make it like that. Now, this area would be 6x, but that's not a square, right? That's making a rectangle where these two dimensions are no longer the same. So we won't be able to take advantage of the square symmetry. That's our whole goal. So I'm not going to break it up. I'm not going to put all 6 there. Instead, what I'm going to do is put 3 there. So that's 3x. And then I'm going to put the other 3 down here. So now, beautiful, we're still got kind of a square working. We just got to fill in this last portion. And look at that. 3 times 3 is 9. It's exactly the number we wanted. Beautiful. So what does that mean? X plus 3 squared is equal to 16. Voila. Now it's a level 2. You get this whole time, level 3, we're just level 2 in disguise. Who knew? I knew, and now you know. So now this is a level 2 problem. It's really quite beautiful. Something squared is equal to 16. That means that something has to be plus or minus 4. All right, so I'll just start with the plus 4. So that's 1. That's one of my answers. Or that something has to be negative 4. And so that's my other answer. Lovely. Level 3 problems. And actually, let me do another one for you before I start to ask you, what do you think a level 4 is going to be? But I'm going to hold on to that question for a little bit. Let's do another level 3. All right. Well, this board's slipping around. I only got a chair holding it up. So if it falls over, you got to blame the chair, not me. All right. It's not my fault. All right. So here's another level 3. Let's do x squared plus, let's do 10x plus 25 is equal to 17. Now, if you've been working with perfect square trinomials, you might already be looking at this and be like, Mr. Mill, that's another perfect square trinomial. You just put 2 straight perfect square trinomials. Because one of the things you're going to see is that in level 3, they start off as perfect squares already. And in level 4, they're not perfect squares, and we just make them perfect squares. Because that's what we do. We're taking, it's called the square method, right? The square method. So let's do this. I'm going to build it first. Got my x squared there. X times x. Oh, I got 10 x's. I'm going to put 5 of them on this side and 5 of them down here. Again, taking advantage of that beautiful symmetry. So I got this one part of my square that's not filled in, but look at its dimensions. It's 5 by 5, so it's 25. And voila, perfect square. So what do I got now? I got x plus 5 squared is equal to 17. It's a level 2 problem. Something squared is equal to 17. Brilliant. So what I'll do now is that means that that thing that's being squared is going to have to be the square root of 17 because that's not a perfect square. So it's going to be square root of 17 times the square root of 17 is 17. All right. So I know that x plus 5, and I'm going to stack the plus or minuses this time, have to be plus or minus the square root of 17, which means x is going to be plus or minus the square root of 17, take away 5. And one of the things to recall is that we're not going to be doing much rounding here. So when it comes to a radical, if it's not a perfect square, then you can bet you're going to have a radical in the answer. The thing we do have to do with radicals is we have to simplify them. Now, luckily, we got a nice prime number, couldn't simplify it. In this next example, I'll make sure that we have to simplify that. I don't want to miss out on that fun. All right, so level 3. Feeling pretty good here. All right, so let's do another one. Let's go x squared minus this time, minus this time. Give me a number. Okay, I heard what you said. You wanted 14. That was a nice number. That's a good call. Equals, let's do one of our favorite ones here. Let's do 75. That's a fun number to reduce. All right, so here we go. Increasing our flexibility. And don't you worry. Eventually, it won't matter if this is a perfect square. And the sun's kind of in my eyes, but it's beautiful because I've been indoors so much lately. I feel good being outside. I had a glass of water. I don't know where I put it. Oh, there it is. All right. Dog is digging a hole under the under the porch. Ay, ay, ay. All right, so here we go. We're going to build it first. X squared. You don't have to build it if you don't want. I rather like doing it because I'm not really that much in a hurry right now. So here's the trip. Here's the first trip. It's not very geometric, right? Is that we're actually going to have to just kind of accept the notion of negative area. It's a little bit hard to understand what a negative area would imply, but the existence of negative areas is required for all the mathematics to work in every case. So in this case, the negative 14x, I'm putting -7 and -7, still taking advantage of symmetry. I still have this one spot missing, but if I go -7 times -7, I get a positive 49 area. All these values add up to what I started with up here, right? X squared plus 14x plus 49. So now what I can do is take advantage of what I know of squares and create a beautiful level 2 problem. All right, nicely played. So I know now that x minus 7 is going to be plus or minus the square root of 75. Now, one of the steps I'm not showing, but you could, if you wanted to solve it that way, is you could just algebraically square root, because square rooting something squared gives you the middle. And then you, of course, would have to square root the other side, because whatever you do to one side of the equation, you got to do to the other side of the equation. Hence the balance, people, hence the balance. And now when you take a square root, if you always put plus or minus, which you should if it's an algebra problem, then you always get the right answer there. All right, 75 we got to reduce. I'm feeling like doing the tree method because I think it's pretty cool. It's not necessarily the fastest method, but I think I already told you earlier I'm not too worried about speed right now. All right, so there we go. One of the things what we've just actually learned is that 75 is 25 times 3. And since 25 is 5 times 5, 75 is actually 5 times 5 times 3. And it's a beautiful property of every single number in existence. Every single number can be rewritten as a product of prime numbers. These are all prime numbers, okay? Now, root 5 times root 5 is just regular 5. And there we go. So then my final answer, and I should probably just like maybe bubble this or at least box it in, should be, whoa. So from here, I'm gonna start down here. Am I still on the screen? Barely, right? But barely is good enough. So we actually know that x minus 7 is now equal to plus or minus 5 root 3. So now I'm going to add 7 plus or minus 5 root 3 plus 7. Level 3 in the books, everybody. I hope you're well. Take care of yourself. Be kind to each other and stay hip.